Hello everybody, glad to see you. Today we're going to talk about position control. At top we are going to control the center of this hole by this FCF. We have positioning control, we are going to have cylinder with a diameter of 0.01. We have modifier MMC back to ABC. A is this plane, B is this plane, and C is this plane. It means this cylinder should be perpendicular to A. And center of this hole should be in that cylinder. At bottom, we are going to have the same geometry, but in this FCF, we don't have reference plane A. We have B as a primary reference plane. What does it mean? It means the axis of this cylinder with a diameter of 0.01 should be parallel with plane B. As we can see at bottom right, this hole may not be perpendicular to A. If A is mating surface, it is really important to have A as a primary reference plane. In other words, we are going to have another geometry as we can see here at the bottom right. Here we are going to have this positioning control for this threaded hole. As we can see at top right, after assembly, we may have interference between bolt and top plate. In order to avoid this interference, we are going to have another modifier with the name of projected tolerance zoom. As we can see at bottom left, this P is here. We have one number after that is going to represent for which length or height we are going to project the tolerance zoom. At bottom middle, it is shown this cylinder with a diameter of 0.3 and let's say height of 14. The axis of that hole or threaded hole should be in that cylinder in order to avoid any interference. Here at the top we are going to have another example. It is another way of showing this modifier P, and this length is written here. As we can see at top right, it means we are going to have a cylinder with a diameter of 0.01 and height of 0.25, and the axis of this threaded hole should be in that tolerance zone. At bottom, we are going to have another example. We have modifier P here, projected TZ, but the length of that is written here in the figure. It is another way of showing this modifier. Here, I will talk about this fastener. We are going to have two different type of fasteners, let's say fixed and floating. We are going to have some, let's say, parameter with the name of H is going to represent hole diameter, F is going to represent fastener diameter, and T is going to represent tolerance for both of them, for floating and for fixed. And here for fixed fastener, we are going to have P is going to represent the length of projected TZ, and D is the depth of the thread. Besides this, all tolerance for positioning for, let's say, hole and fastener for top and bottom, we need to consider two other parameters with the name of round out, as we can see here at bottom right, and also straightness of the fastener. As a last example for today, we are going to have these two floating fastener, two M10, and we have part A and B. For part A, we don't know what should be the tolerance for this position. TZ for this position in control. We are going to use this formula. T equal to hole minus fastener. Always we are going to talk about the worst case or MMC situation. For the hole, MMC for this hole, the smallest diameter of the hole, we can see what should be. It is 10.25 here. And for fastener, MMC is 10. In this way, we are going to calculate what should be this tolerance for this hole, as it is calculated here, and you can see here. For part B, again, we don't know what is the value of the hole diameter. We have this T tolerance, and then we are going to have T plus fastener diameter. We can calculate the hole diameter. For now, I would like to close this session. In coming session, I'm going to present several examples about these fasteners, and then I'm going to continue this positioning control. We are going to have many different topics. I'm going to talk all of them in detail. Thank you for today. I hope you enjoyed. See you next time.